Today, we're digging into the 4 gas laws, rules for how gases react when you mess with them. That's Boyle's law, Charles's law, Gay-Lussac's law, and the combined gas law. They're all about volume, pressure, and temperature, and how they relate to each other in gases. Volume's how much space the gas takes up, measured in liters, simple enough. Pressure is the amount of force that gases exert on surfaces and walls. Think kilopascals, atmos, whatever works. Temperature is, temperature, how hot or cold the gases are, measured in Kelvin. Celsius is no good. Convert Celsius into Kelvin, just slap on 273 degrees, and that's it. In most gas law questions, you will have an initial and final equation, and you have to do the math and see what changes. First up, Boyle's law. It says if volume drops, the pressure goes up. Double one, half the other. Temperature stays constant. So in short, temperature and pressure work inversely. Squish a balloon to half its size, and the pressure doubles. Your lungs use this to work. Next, Charles' law states that as temperature increases, so does the volume or the space gases occupy. Heat it up, volume grows. Cool it down, it shrinks, as long as pressure is kept constant. Triple the temperature from 100 Kelvin to 300 Kelvin, the volume triples. As the gas molecules warm up, they occupy a bigger and bigger space. Gay-Lussac's law is the third law. It says that if the pressure is lower, so is the temperature, as long as the volume and amount of gas are kept constant. As temperature increases, so does the speed that gas particles move, making them hit and exert more forces on surfaces. And finally, the combined gas law, which is a Frankenstein of all 3 gas laws. And this is the formula. Plug in the numbers for each value and solve for what's missing. Let's do a practice question. A 5-liter container of gas is at a pressure of 2 atmospheres and a temperature of 300 Kelvin. If the gas is transferred to a 10-liter container and the temperature is increased to 400 Kelvin, what will be the new pressure of the gas? First, you have to rearrange the formula so it matches what you're looking for. Then you plug in the values. And finally, you calculate. And if you got it right, you should get 1.33 atmospheres. Thank goodness we have calculators, or doing these gas law questions would take a mighty long time. So that's your gas law questions. Squeezing, heating, and smashing air to make it work.